All right, now in my previous video, I clicked the wrong button and then the video stopped. So I have to start over, sorry. So let's continue with problem 37. 37 says that, there's a bacteria that doubles every 20 minutes, all right? And the initial population was 1350 bacteria, and we need to write the equation and so on. So we're going with this part of the equation, right? And then so the doubling, first we'll work to figure out what k is. To do that, we have the doubling, so we have a0, okay? a0 times times e to the power k, doubling is what, 20 minutes? Yeah, k times 20 will give us 2a0. So that, so the doubling, we don't care what a0 is, we'll be able to figure out k from it because the a0 cancels out on both sides. So then let's calculate this. Now, give me a second here. So to solve this equation, we'll take the natural log because the natural log will knock out the e, okay, right, in this plan. Okay, natural log cancels out with the e, so we left with whatever's up there. So let's take the natural log of both sides. So we have natural log 2 that equal to natural log and e cancels out. Okay, so then we have only the k times 20 left. So then k is equal to natural log of 2 divided by 20. That will give us k. All right, so now that we have the k, then we have we got our equation basically, because we have the initial amount, which is the formula says 1350. All right, so 1350 is initial amount, and then e to the power k is that thing, okay? Ln 2 divided by 20 is the k, and then times the time t is our formula. Now we haven't written, we haven't calculated the k yet, but we can do that anytime we want, okay? Yes, now let me see. Now the answer at the back of the book does want to know what is k, so let's do that, okay? Okay, so natural log, calculating k, natural log of 2 divided by 20, that equals 0.346 or something. That is, yep, that is correct. Okay, that is the same as what the back of the book says. So we got k. So the next question of this problem is, what are we doing? And, well, I better move this up. Okay, the next question is population size after 3 hours. Now there's a slight trick here because the number here, original number we got was actually in minutes. It only said 20 minutes. So if t is to be 3 hours, then t has to change to 3 hours times 60 minutes. That is, we're talking about 180 minutes total here. Okay, so the question is, what's the population after 3 hours or 180 minutes? So let's do that. And to do that, we will follow this formula again. Okay, and I will clear it out and let's type it in. 1350 times shift natural log, that gives me the e. Let's see, parentheses. All right, parentheses. Natural log of 2 over 20. So I'm going to type in this formula again instead of writing down the decimal point because that gives them a somewhat more accurate answer. And ln of, so natural log of 2 divided by 20. No, sorry. I will have to do the close parentheses. Okay. So because natural log comes with this parentheses and only applies to 2. So, okay, divided by 20. All right. And then close parentheses, that's the end of e business, right? And the next thing will times t, which is 180 minutes, times 180. And let's see, nope, the 180 is still on e. I need to get rid of it. Okay, because is it on E? Yeah, actually it is. Right, it is. The whole thing is in the E business. In fact, I should probably put parentheses here to remind you to do parentheses, just to be secure, so that the calculator know what we want. That should do it. And let's see what it says. Oh no, I got an error. Okay, let me figure out where I messed up. Okay, I think what I'm doing is I have one too many parentheses right here. That after 20 I have a close parentheses, and I'm not supposed to do that. Okay, I got rid of it. Let's try again. See if, yep, now we got the answer, and that is exactly the answer at the back of the book, 691 and then 200. So that is the end of problem 37. So next, let's look at, what's the next one? Let's look at, let me see. So next, let's do problem 39, which says that there is a count of bacteria that is, A0, we don't know what it is, but we have more information that can help us figure it out. Okay, it says that at 5 minutes, right, there is 360 bacteria. So let's write that down. So we have 360 bacteria following this formula, 360 e to the power k times, what was it, 5 minutes? Yeah, k times 5. That is, no, sorry. This is A0. This equals to 360. 360. All right. And this is just A0, because we don't know what A0 is yet. Because A0 is the beginning number of bacteria, and it doesn't say what it is. It only says after 5 minutes, it is 360. So right now we don't know what it is at time equal to 0 minutes. So so this is all we know. But there's more information though. And it also says that the bacteria becomes 1,000 after. We still don't know what A0 is, okay? And I should write down, this is problem 39, okay? 39, there. All right, so, but we have more information. That is, this is e to the power k times, what time is this? 20 minutes, all right? So even though we don't know what A0 is, we have 2 sets of information, and with that we should be able to calculate k, and we're going to do it by doing a division. Okay, we'll take this equation and divide by this equation like this. So we'll draw a division line right here, and this is equation 1, okay, and this is equation 2. Now if we take equation 1 divided by equation 2, the A0s will cancel out, and then we will just have this stuff left and that stuff, and with that we should be able to calculate what k is, because then we get an equation that has only one variable in it. So to do that, we have we'll cancel out one of the zeros, okay, like that. So it's a little simpler. We have 336 over 100 equal to e to the power. Okay, now then we have e here, e doing division, and remember division is the same as subtraction, basically, when we do exponents. So then, so b minus y is the same as 1 over by, and or put it, yes, put it this way. Maybe I should write it down here. Another way of saying this is bx divided by by. Okay, if you do this, this is the same as b to the power x minus y. That is quite packed, but anyway, so then we're going to do the k5 minus k20, e to the power k5, that's 5k, minus k20. Okay, and that is going to, we'll write that as 0.36. And this is going to be e to the k 5 minus 20, that's negative 15k. All right, and let's draw it like that. All right, so then, so now we'll do the same trick, okay? We'll slap natural log on both sides, which will get rid of the e. So natural log of 0.36 is going to be equal to, natural log and e cancels out each other. We'll have left with minus 15k, or that is k is equal to ln 0.36 divided by 15, and that is the value of of k in this equation. So if we plug that in there, then, well, let's plug that in there, okay? Our original equation says 360 is equal to a0 e to the k times 5, okay? That's the original equation, right? Now we know what k is, so to solve for a0, we'll take 300 and divide it by this. That will give us what a0 is, and that's what we're gonna do right now, okay? Let's take 300 and divide it by e to the power k, k times 5, where k is this thing, and we'll type all that into the calculator. All right, so I will do it like this. Let's clear out the old problem. Okay, now so we're looking for a0, right? So then we need so we take 360, right? Yeah, and then divide by e to the power k to the k times 5. So start typing. We have 360, and then divided by e to the power whatever. Let's see, where's e? Shift natural log parentheses, okay, and then we'll put another parentheses around k to keep track of k properly. Although yeah, we'll type like this, okay, because k is a complicated thing, so let's put parentheses around it just to be clear. So let's divide by e to the power, okay, parentheses again. Yes, do we need that many parentheses? I'm not sure. Well, let's do that anyway, just to be safe. So the first parentheses for e, and then the second parentheses is for k. Okay, so then now we type in k, which is natural log of 0.36, close parentheses, that's for natural log 0.36, and then divided by 15, okay, and then close parentheses, that's for k, I believe. And then times 5 and close parentheses again, that's for e. I hope that is correct. Yep, and that is what I have. Let me check to see if this is right. Okay, what does the book say? Now my answer is different from the back of the book. Guess why? When I look at this more carefully, and I realized that I made a drastic mistake here. See, it says minus 15, so it should be divided by minus 15, and somehow I lost my negative sign on the way down here, so then my whole problem went to pot. So then let's fix it, okay? So let's go back to the 15 here. Yes, my cursor is moving. Okay, let's add the negative sign, which then see 256, which is much better. In fact, it's exactly what the answer on the book says. Okay, 256, so much better. Okay, now don't make my mistake and forget the negative sign. Okay, and but if you do, you need to go back and find it and fix it, which is still okay, but not as ideal. So so then A is 256 as we have here, and that would be the answer to let's see, that's the wrong marker. That would be the answer to this thing. We also need to all right. So A is equal to 256. Okay, and 256. And the book also wants us to figure out what k is, which is okay. The answer in the back gives k, the value of k, and so we can also do that to calculate k is and well, without forgetting the negative sign, that really make a big difference. So let's calculate to just punch in k, which is natural log of 0.36 divided by negative 15 close parentheses, and that equals to error. Why is there an error? Oh, sorry. Is the natural log only applies to 0.36. See, I need a close parentheses, and there's no need for another close parentheses after 15, because yeah, it's only log 0.36, right? And okay, because if you because natural log cannot take negative numbers. That's why when it says divided by a negative number, then the calculator is like, what are you talking about? Okay, so that should be better. Yep, 0.06811, which is what the book says as well. Okay, so that would be what you will write down for this part of the answer. But that is not all. Now the book also wants to know something else. What problem are we doing? 39? Right. It says, how long did it take for the population to double? All right. So to calculate doubling, where is our this is our formula. Is 256 is the original number. Okay. And then to double, then it would become we need to know what happens when this thing equals to double of this, which is let's see, isn't doubling time is calculated differently. Let me think. Now to calculate doubling time, we just write down something like this. This is A0, okay? We don't even care what it is. It needs to become 2A0 because the A0s cancel out. Then we have e to the power kt, where we need to know what t is because we're looking for doubling time, but we know k is this thing already. So then, so if we cancel out the a, and then we just figure out that we'll do the same trick, natural log of 2, okay, that destroys the e, and then divided by k, that would be equal to the t, and that is the doubling time. Yeah, so let's do that to figure out what the doubling time is. So we have, let's clear that up. So let's punch in the whole thing again. That will give us a more accurate answer. Natural log of ln of 2 divided by, sorry, I forgot, I made the same mistake again. Close parentheses, thank you. Divided by, what's k? K is natural log of, we need it in parentheses, okay? That's a natural log of ln, 0.36, close parentheses for natural log, and divide by negative 15. Or you can just punch in the decimal number that we already got, but this way it is slightly more accurate. Yeah, so that should do it, which is 10.17, and as the, so 10.17 is the answer because the book says about 10 minutes. So doubling time is about 10 minutes. 10.17 is, yeah, close enough. So that is the answer to the second part of problem 39. Next, let's do problem 41, cooling soup. A pot of warm soup had an internal temperature of 100 degrees. That's not really that warm. Was taken off the stove to cool in a 69 degrees room. After 15 minutes, the internal temperature is 95 degrees. So how long would it take the soup to cool to 80 degrees? Okay, so we are following this formula, which is the soup cooling or any cooling formula from Newton. Now remember, for the cooling formula, it includes this temperature. This is the temperature of the surroundings. Okay, and then this is no longer the initial amount. Okay, it's just some number right here. Okay, it is not the initial temperature or anything. So the A0 is, there's nothing zero about it. We'll get rid of the zero. It's just A. Otherwise, the formula reads just like it. And so knowing that, let's do this. So starting out, it has the original temperature is equal to 100 degrees. All right, so 100, and then Fahrenheit is equal to A, okay, times e to the power kt plus t. The surrounding temperature is 69 degrees. And we'll skip the degree bit. 69 degrees. So now when t is 0, this number is not just t, this is actually 0. So this is the initial situation. When t is 0, then this number is going to be equal to 100. in that case, e to the power 0 is 1, which means we can calculate a, okay? So this thing is just 1. So a, the value of a is 100 minus 69, which is equal to 31. So that is the what a end up being. And then and so the next thing, now that we know what a is, we need to, after 15 minutes, we need the next piece of information, which is given to us right here. It says that, okay, so a is 31, right? It says after 15 minutes, so e k times 15. Now the time is 15 in minutes. After 15 minutes, the internal temperature has gone down to 95 degrees. Now the surrounding is still 69, so we'll keep that like this. So, yeah, was after 15 minutes, soup is down to 95 degrees. And then, and now we're good, okay? Now we have an equation that has one unknown in there, which is k, and we need to, well, take k out. Okay, and once we've done that, then we have the entire formula for the soup business. So let's do that. Okay, well, to get k out, we need to take 95 minus 69 to throw the 69 over there and do the minus. That would be 26. 26. Yeah, okay. So you can do that with a calculator or in your head, whatever, and hope. And then next step, we're going to divide the 31. So that's 31. Next step, we need to get rid of the e. So let's write down the natural log. And finally, we need to divide by 15. Divide by 15, and that will leave us with k. Okay, after we do all that stuff. So this is the value for k, which is good. And we can punch it out if we want right now. Okay, and the book, let me see the answer. Does the book want us to? No, the book doesn't care if we punch it out. No, doesn't care about what k is. It just wants to know the question, which was to be known later. Actually, we'll know it right now. Okay, 80. The book wants to know what is the temperature. What time would it be when the soup is 80 degrees? So let's write down 80. Okay, and then 80 equals to, so we have the same equation, okay, the 31e and then k times 15, yeah, and k times 15 or 15k, either way. That's a 31e k 15 plus 69, and this is what am I talking about? No, t. We need t, right? Because it says what time. So now we know what k is. We need to know what's the t that will give us the answer. And in this case, we know what k is. So we need to solve for t in this case. So that's what we're going to do. And to do that, we have, I'll write it over here. So we need to throw the 69 over there. We do the same thing as here, okay? We keep doing the same thing, same job. So let's throw this over there. That's 80 minus 69. That is going to be 11, right? So that's 11, okay. And then next we get rid of the 31, push it down here, divide by 31. And then we get rid of the e by taking the natural log. Okay, and then we divide by k, which is that thing over there. That whole thing there is k. Okay, this whole deal. Now, once we've done that, we get our time. This is the time. That equals the t. So now all we have to do is punch it into the calculator. Now, a lot of times people would like to, if they don't know how to do some problem, they like to grab the calculator and start punching in numbers because that makes them feel better. That is a complete waste of time, okay? You only start punching in numbers when you know exactly what you're going to be punching in. That is, you should be able to have, basically write down this thing, and anybody can punch in the number by following the what it says. So that's what we're going to punch in, is this thing, bearing in mind k is over here. Maybe I should do it, where should I do this? Okay, I know, I'll write this thing over there, okay? Okay, I wrote the same thing over there. Natural log 11 over 31 divided by k, where k is this thing right here. So let's punch all that in, and I try to do that. And you can see it on that screen what we're doing, okay? So let's see, what are we doing? Natural log 11 divided by 31. Wrong, I screwed up again. Look at that. After natural log, we need to close parentheses. That way the calculator knows, no, wait a second. We are taking the natural log of 11 over 31. Never mind, I didn't screw up. I screwed up by thinking I screwed up. So anyway, divided by 31, close parentheses, that's what we're taking natural log of, okay? That entire fraction. And then divide, so that's the top part, okay? That's good. And divided by k, we'll put parentheses, k in parentheses, okay? K equals to the natural log of 26 divided by 31, okay, that whole thing is inside natural log, the whole fraction, all right, and then divided by 15, okay, and then close parentheses, okay, that is the close parentheses for the division symbol, and that should be okay. Let's hope this is right. Okay, I got something like 80 minutes. Nope, 88 minutes, and that is exactly what the book says, about 88 minutes. Yay! I finally did one thing without making a mistake. All right, that's always so exciting. All right, so next problem. Next, let's do problem 49. Okay, now let's see, 49. We have, I'll write it right here. Problem 49. All right, so it says that the formula of earthquake is m equals to 2/3 log s over s0. Now, what does all of that mean? M is probably mean magnitude, right? So we'll write that down. It says that the magnitude of some earthquake is 3.9. So 3.9 is going to be equal to 2/3 log. I'm just writing down what the book says, okay? Log s over s0. All right, so far so good. But what is s over s0? We don't know, and right now we're not concerned about it. So the second earthquake is 750 times as much energy as the first. We'll take that, we'll assume that has something to do with energy. Okay, so we will, so the second earthquake, whatever it equals to, is 750. So we'll stick the 750 in there. So the second earthquake, okay, let's see, I'll write it down. So 2/3 log, so this is for the second earthquake, okay, dot. Second earthquake, 2/3 log, 750 times whatever this stuff is, okay, we'll assume that means some kind of energy calculation. All right, so then what does that mean? That equals to, now remember the logarithm of products, okay, c times d is the logarithm of, you can break them down into addition. So this is the same as 2/3 log of just that part, okay. Well, first 750, let's do 750, okay, plus log of that thing. Log of, let's see, I better write it down here, plus 2/3 log of s over s0, as we had before. Now this part right here is 3.9 as given to us, okay? So this is 3.9, and then this part we can calculate. I mean, we know we can use the calculator and figure out what all this stuff is. So let's do that. All right, so let me stand a little closer. And okay, now we are doing, so we have this thing, we're doing this thing, okay? So we have 2/3 times log of, oops, sorry, I typed in ln, delete, okay? Log of 750, right? 750, close parentheses, all right? Plus, that's the first part, plus the second part is 3.9, which is given to us, okay? That's 3.9 plus 3.9 all right, that equals to some number is a 5.8, and that is the answer. And let's see, problem 49. Yep, the magnitude is a 5.82, and that is the new magnitude of the earthquake. Okay, so that's how you do a math problem without really knowing what the symbols mean or much. You just sort of know. Okay, it says 750 times more than whatever that is. Well, then we just we'll crank it out and see if anything good comes of it. All right, so that's that. All right, so next, let's do problem 51, where it says that there's the formula. There's a specific formula right here, okay, which says it gives how many people has heard the rumor after a certain amount of time. So then how many people have heard the rumor after 3 days? So all we have to do is plug 3 into this formula. So please do that, and I will. Okay, that's the bigger it gets. Maybe I should put this thing right here. I hope that it doesn't fall off. And yeah, if nobody touches it, then it should be okay. So I'm just going to punch this into your book. Okay, please look at your book for the formula. If you can't read the screen, read my thing there. Divided by 500 divided by, this is just a matter of punching stuff into the formula. 1 plus 49 times, let's see, shift e to the power minus 0.7 times t was 3 days, right? Times 3, and no, I don't think e has a, yeah, okay. And then get out of e. I push this button to get out of there, okay? Then close parentheses, and that should do it. So I have 71. Wait a second. Yeah, 71. Is that right? Yep, it's 71 people or something like that. A quick, easy problem. Okay, so next let's do problem 53, where we have we're back to this formula again, just the black part. Okay, so then we have 13 milligrams of radioactive dye. That's A0. Okay, we got the 0 back. So A0 is, I believe, 13. Well, first let me write down. This is problem 53. All right. So we start with now we don't have enough space. We have 13 milligrams. I'll write it over here. Okay, 13 milligrams of radioactive, that's A0, e to the power k. We need to figure out what k is, and that decays after 12 minutes, K12, and that would be equal to down to 4.75. 4.75, okay? And then we just need to calculate figure out what k is, then we're good. What kind of answers does this thing give? 13 e something, yeah. It has, see, if you look at the choice of answers, answers B and D looks about right. In fact, answers, answers C and B and C looks about right, okay? The answers, the other answers are not quite correct, I don't think. But they could be, I suppose. It really depends on certain things. Let's crank this out and see what it says. Okay, so then to do this, we do the same thing we've been doing. So we get rid of the third. We need to calculate k. Okay, so to do that, we need to get rid of put the 13 on this side, 4.75 divided by 13, and then we'll take the natural log to get rid of the e, and then we divide by 12 to get rid to have just k left. Okay, and so next we will use our calculator and figure out what that thing is. So I will clear it out and then type in natural log of 4.75 divided by 13 close parentheses, right? That's just the natural log part, okay? And then divide by 12, and that should give us what k is. Is k something? It's minus 0.839. Okay. Is there anything that has, yep, answer C has minus 0.839 in it. And that would have been my guess anyway, but now is set. Okay, so once you plug in k equals to minus 0.839, then the equation would be 13. The standard equation would be 13e kt. Okay, with k being 0 point whatever, 0 negative. Yeah, don't forget the negative. And negative 0.0839 in the place of k, and that should be the equation. Is that, yep, that is what this book says as well. And that marks the end of this section.